Okay, a little bit on the coefficient of friction. This is really a second year topic, but there's so many questions in exercise books which use it. It's just easier to introduce it now. So if you've got two rough surfaces, there's a unique coefficient of friction between them. So for instance, the coefficient of friction between this board and this pen case, which is kind of, yeah, making a reasonable attempt to slide it down, is going to be different to the coefficient of friction between the board and the calculator. Coefficient of friction, so 0 is completely smooth, there's no upper limit, but normally coefficient of friction is relatively small, so most of the ones you'll see will be between 0 and 1, but they can be quite high. The other thing about friction is it's dependent on the reaction force. So if I'm pushing this book along, I can push that quite easily. But if there's a force acting down on the book, it becomes harder to push along. So by pushing down and creating a stronger reaction force, that increases the friction between the two surfaces, which leads us to this formula, which we use in math. I think physics you do a little bit more on stationary friction and moving friction, but this is all we do in maths. So F equals mu r, and this is F max equals mu r. So for maximum friction, you either have to be on the point of sliding, so by tilting this plane up I can get literally on the point where it's just about to slide down, or actually moving, and then friction's at its maximum. If there's no movement and I lower that little bit more, there's going to be less friction, and so this equation only holds for maximum friction, so when things are moving or on the point of movement. So the stronger the reaction force, the more friction. I'm going to start over here. So this particle is being pulled along. The coefficient of friction between the particle and the surface is 0.2, and so we can work out the frictional force if it's moving along by doing F is equal to 0.2 coefficient friction times the reaction force, and the reaction force will be equal to 10g because the forces are in equilibrium, are perpendicular to the plane. So F max is equal to 0.2 times 10 times 9.8, which gives you 19.6 newtons. So if that object is going at constant speed, then at t will equal 19.6. Going over to this one, so just resolving forces as well to find the maximum friction. So this one's being pulled up the slope, so the frictional force will be going in that direction. The reaction force is here, and then we have the weight coming down, which is 9g. So in order to find the reaction force, we can resolve perpendicular to the slope. So these forces are in equilibrium, and R is equal to, I'll call that one alpha. Then I'm interested in this one here, because it's this bit here that's going to equal R. So R is equal to 9g cos alpha. We've been given sine alpha. The thing I don't want you to do is do shift sine of 3 divided by 5 and then do cos answer. I was just going to say, because your calculator doesn't give you it exactly, and it just did. But just something I would think about doing here is, if that's alpha, I know that sine alpha is opposite over hypotenuse. And so if you just do Pythagoras around here, you can work out the length of this side here. So 25 minus 9, 16, square root of 16 is 4, so 3, 4, 5, right angle triangle. And so cos alpha is equal to 4/5. So r is equal to 9 times 9.8 times 4/5. We will do a bit more work on friction in maths next year, actually, but it's kind of easier to introduce it now. So that's 70.56. And so if we want to find this frictional force, if there's motion, or if it's on the point of motion, then the frictional force is equal to mu, which is 0.25, times 70.56. Which gives you 17.64. If that's an answer, you'd probably want to round that to 2 sig fig. But certainly within your workings, I'd work to better accuracy than that. So I think that should be enough to just tackle a couple more questions, but they involve actually finding the frictional force as well. So it's the same exercise, so exercise 2A. Question 14, which I wrote wrong on the last video, sorry, I meant to write 13. So question 14 and question 17. So you'll need to use this to find the friction for those. Yeah, I think that's what I want to say.